Sharks are a keystone species. They balance lower trophic levels, increase genetic diversity, keeping our oceans healthy. By doing this, they drive up to $30 billion per year in tourism revenue and directly employ over 2 million people in the Caribbean islands. Seeing how important sharks are to us has led me to ask the question, to what extent have coastal shark populations adapted to overcome pollution of the anthropogenic roots? My name is Alexandra Rivera, and today I'll be talking about the impact of anthropogenic pollution on coastal sharks. After doing some research, I have found that coastal shark populations are being negatively affected by anthropogenic pollution. And although some sharks have adapted to better survive these changing oceanic conditions, these adaptations are unsustainable in the long term. We'll be focusing on three main aspects of anthropogenic pollution: wastewater, which comes from coastal urbanization, hydrocarbon pollution, and fossil fuel emissions. Let's begin with wastewater-driven eutrophication. In rapidly urbanizing societies, organisms adapt to improve their survival, a phenomenon known as urban evolution. In a source provided by College Board, Eric Bender reported that Daphnia, water fleas, in urban ponds have significantly higher body fat percentages than do rural water fleas. The same thing happens with urban sharks. Sharks that live in urban areas have higher body fat percentages as well as more saturated fatty acid concentrations. This highlights the changes they've had in their behavioral and feeding patterns. However, with urbanization comes a big problem: wastewater. Wastewater leads to excess nutrients entering our oceans, which leads to algae blooms and bacterial blooms, which deplete the water of oxygen, a phenomenon known as eutrophication. This can potentially be deadly, as sharks who cannot escape these oxygen-depleted waters wind up dead. Hydrocarbon pollution. In a study conducted by Jassim Al-Hassan at Kauai University, he found that polycyclic aromatic hydrocarbons, PAHs, have the potential to be incredibly deadly to sharks. They cause tumors, changes in joint formation, and DNA damage. The saw shark had the highest total concentration of PAHs, with a grand total of 72.96 micrograms per gram. They also had benzopyrene and dibenzoanthrace, powerful carcinogens. 2 baby milk sharks were tested. They had grand totals of 32.33 and 60.02 polycyclic hydrocarbons. The second milk shark also had benzopyrene, a carcinogen. This shows us that they're getting these dangerous chemicals from their water, from their food. And to make matters worse, a black-tipped shark was dissected and 2 fully developed unborn pups were found in her stomach. They had concentrations of 2.19 micrograms per gram, meaning that this can have a generational impact. And this reflects onto us because we're the reason these hydrocarbons are reaching the water, since they come from oil spills and fossil fuel combustion, fossil fuel emissions. Dennis Heinrich at James Cook University found that 40% of CO2 emissions come from us. 30% of those emissions are absorbed by the ocean. This leads to ocean acidification. The water absorbs the carbon dioxide and becomes more acidic. It also makes the water warmer and leads to hypoxia, depletion of oxygen. Well, so how do sharks adapt to these changing conditions? We'll be looking at buccal pumpers and obligate ram ventilators. Buccal pumpers are sharks that breathe using their mouths. They don't need constant motion to respirate. We'll be looking specifically at the epaulette shark, a shark that lives in coastal reefs and flat lagoons, areas that typically experience hypoxia. The study by Dennis Heinrich found that these sharks were not typically affected by hypoxia. Their metabolic rate stayed constant, and acidosis was prevented by ion regulation seen by their plasma bicarbonate levels, which rose. as they prevented their blood from becoming acidic. But however, a different study by Johnson found that epaulet shark embryos reared in CO2 had significantly higher mortality rates, which means that buccal pumping sharks are not safe. Obligate ram ventilators are sharks that need to continuously move to respirate. We'll be focusing on the sandbar shark. A study by Daniel P. Clear, a member of the Virginia Institute for Marine Science, found that sandbar sharks combat hypoxia by swimming faster and keeping their mouths open. This is ultimately unsustainable because their metabolic rates increase and they need more oxygen and less oxygenated water. They're losing nursery space because of hypoxia, which will ultimately lead to population decline as baby sharks are forced to venture out into the open ocean in search of more oxygenated water. So what can we do about this? And in reality, there's nothing we can do to reverse the damage we have done. However, there's stuff we can do to limit the impact we're having. First, we can look at wastewater management reforms. Installing these septic systems will decrease eutrophication and ultimately hypoxia by limiting the amount of nutrients that can enter our water. However, a big limitation to this is the cost. They're very expensive, and additionally, they're not 100% effective. Pollutants will still enter our water, and pathogens will still enter our water. They will simply reduce the impact we're having. We can also limit fossil fuel emissions by replanting forests. But the biggest issue with this is space. Humans are very overpopulated. Finding space to replant entire forests will be very hard and very expensive. Lastly, we can fund scientific research. There's technologies being developed that can quite literally suck carbon dioxide out of the water. However, time is the biggest issue. It'll take a lot of time to develop more technologies and make them widespread enough to resolve the issue. Thank you.
All right, 2 questions for you. First question, how valid and reliable were the sources that you used, and then how did you know?
My sources were very reliable. They were all peer-reviewed journals, except for the picture of the dead shark. And yeah, they were researched by professionals with marine biology degrees. They knew what they were talking about.
Okay. And if you had more time, what additional research would you have conducted?
I'd really want to focus on shark populations because I couldn't really find any numbers with the amount of time I was given. So if I had more time, I would look at how the population numbers are changing and where the populations are headed in response to the hypoxic conditions.